Today we are going to see hydrostatic forces on surfaces, that is from fluid mechanics, and in that we are going to study the forces on surfaces, that is horizontal, vertical, inclined. So the definition of total pressure we have: when a static mass of fluid comes in contact with a surface, then it will exert force on it. And that force is known as total force. And this force, this is most important, this force is always normal to the surface. That is most important. Now, center of pressure we have, that is the point of application of total pressure. So we have to find its application, and then that is known as your center of pressure. Now we have total pressure on a horizontal plane surface. So now we will consider a plane surface which is immersed in a static mass of fluid. So this is horizontal surface. So my all points of the surface are at same height from the surface of the liquid. So the surface is held at a distance h below the free liquid surface of the liquid, and the pressure intensity is constant over the entire plane surface. Now you can see my all points are at same height from top, and therefore my pressure on any point on this, because this is horizontal, so its distance is h from liquid surface, and therefore pressure on all we have same, which will be gamma into h. Now, if I have to find out total pressure on it, then I have to multiply it by area. So, total pressure on the horizontal surface, we have gamma A into H. So, we have multiplied it by the cross-sectional area of the surface. Then we have second total pressure on a vertical plane. So, here we have again same, consider vertical plane surface immersed in a static mass of fluid of specific weight gamma as shown in figure. So we have, this will be vertical surface. It is required to determine the horizontal pressure exerted by the liquid on one face of the plane surface. So we are going to consider this as a plane surface. So we have considered this with unit thickness, and we are interested to find out the pressure on this. Now my each point, that is going to be at a different height from the liquid surface. So now we will have, let us consider a small thickness of the, or small strip of this surface. So having values B and D, and this surface is at a distance h. Let dP be the total pressure on this area. So we are going to get intensity of pressure on this area is gamma into h, and then we will get total pressure on this, which is dP, that is equal to intensity of pressure into area. Now area of this, that is B into dH. So we have this as area dA, and that is B into dH. So we will put dA as B into dH. So we will get it as dP is equal to gamma h into dH. Now to find out total pressure on this, we have to integrate it over the height of this surface. And then we have dP, that is P equal to integration of dP. Now gamma, that is specific weight, is constant. So we have BH into DH. And then by integrating BH into DH, we know we will get this first moment of area. So we have that B into dH, this will be area, and then we have taking moment as, so if we will write it as B into dH, this will be area into H, so this will be first moment of area, and we will get it as AH bar. Here we have written it H into dA, and dA we have B into dH, and therefore we have BH into dH is AH bar, and we will get value of P, that is equal to gamma A into H bar. And H bar, we have centroid of the body from the liquid surface. So we have, this is G, and that is our value of H bar. Now this total pressure P we have at point P, and that value we have gamma A into H bar. Now we are interested to find out this height of total pressure, or I will say it as center of pressure. Then we will go with center of pressure equal to moment of force dp about free liquid surface. So we have to find out distance from free liquid surface. So we will take dp into h. Dp we know, we have b h b dh into h. Gamma is constant taken outside, and then we have b into dh, we have area, and then we have h square. So h square dA, this will be moment of inertia about free liquid surface, because moment we have taken at top, so automatically I will get this moment of inertia I naught, which will be about top. Now we are interested p into, so we have p into hp equal to gamma into I naught, that is moment about top due to P. And from this I will get HP equal to gamma I naught upon P, and that is equal to gamma I naught upon gamma AH bar equal to I naught upon AH bar. So I naught we have, HP we have, gamma I naught upon P. P already we have calculated, gamma A H bar. This gamma gamma gets cancelled. I naught upon H bar. Now I naught we will write in terms of ICG, and we will get it as I naught is equal to IG plus AH bar square. So this is parallel axis theorem. We are going to shift it from free liquid surface to the centroid, and then we will have this. So we will put this as ig plus ah bar square, and if we will put this, then ig plus ah bar square upon ah bar. So if we will take separate, then bar square, ah bar gets cancelled, remains h bar plus ig upon ah bar, and this will gives me value of hp when we have surface as vertical surface. Then we have total pressure on inclined plane surface. So here we are going to consider a vertical plane surface immersed in a static fluid at an angle theta with horizontal as shown in figure. So we have this angle theta, and this is our surface. Now same way we are going to consider a small dA, and we will go likewise. So now here we have, this will be distance y from this x axis, which is at an angle theta to the liquid surface. And from this, if we will see, then we are going to get value of sine theta is equal to h upon y, and we will get h equal to y sine theta. So remaining things we have same. So now gamma h, we have again intensity, gamma h into dA, we have pressure on the strip, and now you can see this is normal to the surface. And then we have h equal to y sine theta. So we can put a dp equal to gamma y sine theta into b into dy. So dy we have that distance instead of dh now, because we have this surface parallel to this, and this is along y-axis. So we have taken this as dy. And then we have p is equal to, we are going to integrate it, dp is equal to, now theta is constant, so gamma sine theta outside, by into dy. Now again in the same way, b into dy is area, and we are going to take y that is about top, and from this we can write it as ay bar is equal to by into dy, and that is integration of y into dA. And then we have pay bar, gamma sine theta into ay bar, but we know y bar sine theta we will get as h bar. So we have this as h bar, and we have this distance we have as y bar, and again in the same way we are going to get it as y bar, sorry, h bar, that is equal to y bar sine theta. And then we have to find out Cp in the same way. P we have calculated. Now we will go for Cp, and then we will get it as center of pressure. Same way we have calculated. Only change we have, moment we have taken about xx, and then we have dp into y is equal to gamma. So we have substituted value of dp, and then we are going to get gamma sine theta outside. Y square dA is, we have again I naught, that is again about x axis. Now p into yp, and that is equal to gamma into sine theta I naught. Same way only sine theta is involved involved in this. Now we have yp is equal to gamma sine theta I naught by p. Then we will substitute value of p. This gamma gamma again gets cancelled over here, and we are going to get I naught sine theta divided by a into h bar. And then Ig we will get Ig plus AH bar square, and substituting this value we have now HP equal to Yp sin theta equal to, now Yp we have sin theta I naught, this gamma gamma actually gets cancelled. So we have this sine theta, and yp we have sine theta I naught upon ah bar. I naught we have ig plus ah bar square. So we have sine square theta upon ah bar outside. And then if we will separate out, then we have ig sine square theta upon ah bar plus sine square theta into a upon ah bar into h bar square upon sine square theta. And then we will get it as, so see we have separated this ig into sine square theta upon ah bar plus sine square theta upon ah bar multiply by, we have h bar square, sorry, this will be I naught is equal to ig plus ay bar square. And we have, that is y bar we have seen. So we have this value h bar equal to y bar sine theta, and y bar we will get it as h bar upon sine theta, and we are going to get this value h bar square divided by sine square theta. And this a already we have taken over here, and then this a gets cancelled, one h bar gets cancelled, sine square theta gets cancelled, so we have h bar plus ig sine square theta upon ah bar, and this we will get for your surface making an angle theta with the horizontal. So likewise we have to find the center of pressure and pressure values for different bodies. So today we will stop here only. Remaining we will see in next lecture. Thank you.